So the polar coordinate system, it's a way of plotting points using r theta. So the radius and the angle. So we're going to do this instead of our x and y. So it's going to still be kind of on our normal coordinate system. Typically we have points x, y, but now instead of plotting to the right or left and then up or down, what I'm going to do first is find theta, the terminal side. The terminal side is where, at whatever degrees I'm at, or radians, where the line would end. So first I find theta, and then, I go out r. Go out a distance of r. So now r is the radius, so instead of my just kind of more boxed x and y values, think of these like they're circles with different radiuses going all around. I'm plotting these, kind of sketching in these radiuses of 1, 2, and 3, but it also goes for, in between would be 2.5 right here, or I can have fractional or decimal, but right now I'm just kind of plotting or sketching in circles of radius 1, 2, 3, and 4. Okay, so first I find wherever my angle is, and then I go out a distance of r. And then the one other thing we're going to have to kind of watch for is if sometimes we might have negatives of each. So if r is negative, then the point is in the opposite direction. The point is in the opposite direction. And then for theta, if that's negative, well, starting at 0, instead of moving counterclockwise from 0 degrees, we move clockwise. So remember that going this direction, it's a positive theta. Going in this direction from 0, this is a negative theta. So we'll kind of carry that over as well. Okay, so let's plot a few points, keeping all of this in mind. I'm going to keep my coordinate system right there. Maybe I'll keep my r theta. So we're going to use r theta. So let's say we want to plot these points. So for A, let's plot A as 4, 2 pi over 3. 4, 2 pi over 3. So if we think about 2 pi over 3, if it helps to think about this as degrees, remember that would be 120 degrees. So first I kind of go to 120 degrees. So there my marker is, that's the terminal side. And then I go out a radius of 4. 1, 2, 3, 4. So right about there is point A. Okay, how about, so that's point A. For point B, I'm going to do this in a different color so it stands out a little more. So there's point A. For point B, let's do 3, 270 degrees. So 3, 270 degrees. So first I go to 270 degrees, which is straight down. And then I'm going to go out 3. 1, 2, 3. Right here. There's point B. Okay, so I've got a radian one, degree one, either way. How about a negative one? Let's go -2, pi over 4. Okay, so first I go to pi over 4. So pi over 4, that's the 45-degree angle in quadrant 1. But now, since it's a -2, I'm going to go in the opposite direction. So I'm actually down in quadrant 3 now. There's my point C. So notice, this would be the same as if I wanted to use a radius of a +2. Let's think about what the angle would be. Instead of pi over 4, add pi to that. That would be 5 pi over 4. Down in quadrant 3. The 45-degree angle down in quadrant 3. So a lot of times we can write these points in a lot of different ways. How about, before we move on, what would be this also the same as with a negative angle? So this would be the same as a positive 2 radius. If instead I went in the negative direction for my angle, it would be negative 3 pi over 4. So notice, all three of these, those are all the same point. We all end up at the same point. Both negative. Negative 3, negative 3 pi over 2. Okay, so first of all, let's go negative 3 pi over 2. So in the negative direction, there, negative 3 pi over 2 is going to be up at, well, at a positive 90 degrees, positive pi over 2. But now if I go negative 3, so right now I'd be here if it was positive 3, but I go the opposite direction. Okay, I'm actually right back on point B. So this is also D. So notice, these are the same thing. Because if instead it's a positive 3, opposite direction there, it ends up being the same point. Okay. How about, let's do one more. How about a positive 2 and 3 pi? So positive 2, 3 pi. So first the angle. So all the way around, that's 2 pi. Another pi would be right here. And then if I go out 3, there is point E. So this would be the same as a radius of 2 and pi. So notice, since 3 pi and pi, those are coterminal angles. Same position, just different rotations. So I could have just right away subtracted 2 pi and gotten my pi and then just plotted that. Okay, so with the different rotations, the negative radius going the opposite direction, there's a lot of different versions of every single point wherever I would land.